Good evening, all participants. Now we are opening session number 2, which is delivered by Mr. Rahul Bhaludas Khara. He is co-founder and Chief Technical Officer, Reset AI, Bengaluru, Karnataka. He is a PhD scholar of Indian School of Business. Mr. Rahul Khara leads Reset AI, homegrown applied AI enterprise on mission to democratize AI for Indian manufacturing, aligned with Indian Swadeshi and Atmanirbhar Bharat vision of technological self-reliance. His work integrates academic research in hybrid ML statics framework with industry-grade interpretable AI deployment across manufacturing, pharma, and legal domains. He has 18 commercial successful patents in AI automation and enterprise application in his account. He is also working across multiple industries and businesses such as risk operations and marketing to build AI solutions rooted in transparency, governance, and responsible AI principles. He is pursuing PhD at Indian School of Business on hybrid ML statics framework. He is an author of Artificial Intelligence Theory and its applications and reviewer of Keeping Your AI Under Control. He has published several international journal papers and widely recognized for simplifying AI for broader audiences. He is Speaker of United Nations for AI for developing countries, and he is a member of MIT Technological Review Global Panel and Harvard Business Review Advisory Council. Now I hereby invite and request to Mr. Rahul Khara to start his session.
Thank you, Kakade sir, for the kind introduction. So, shall we begin the session or how is it?
Yes, you can begin.
Okay. So before I share my screen and begin my session, I would like to highlight what I'm not going to talk about today, right? So our topic is when intelligence consumes energy and sustainability in the area of in the era of LLMs, right? Now there is a lot of information available on web around this topic, that what all we are doing in terms of sustainability or in terms of climate control when we are leveraging LLMs to build AI driven solutions, whether it is for manufacturing or whether it is for any field, right? So I'm not going to give that information to you, and neither I'm going to teach you engineering because you all are much better at that. So what I'm going to do is I'm going to give you an intuitive understanding of how AI solutions are built, how you really even define the problem in AI space before you start building the solution, which is good in terms of uh, ROI. And ROI means not only investment in terms of money, but it also investment in terms of energy consumption. So how you really think about that problem statement and write problem statement where AI should be applied and where AI should not be applied, right? So before I get into the topic of sustainability, I'll give a bit of flavor of what AI is, what ML is, what are different types of personas, so that you have a little background of when I start talking about sustainability and energy in the era of LLMs, right? So before any delay, let me share my screen, and feel free to interrupt in between also, because I don't want to give a monologue. If you have any questions in between, feel free to interrupt. I'll be happy to answer those then and there itself, right? So let me share my screen. And you'll not need my slides because those slides are only bullet points. I am mostly going to talk about it during my session, right? So just give me a minute. So these are topic when intelligence consumes power, sustainability in the era of LLMs, right? Let me start with a question, right? Are you guys aware of agent? At least you might have heard this word agent, right? In AI space. This is one of the most used word nowadays, agent, agentic AI, agentic platform. Have you all heard about it, or do you know what is agent? Because then my question comes, who is the best agent, right? Anybody who knows what agent is in this AI world? Okay, let me define it for you. And again, there are many definitions on web around agent, MCP. We should not get into definitions of those. Rather, we should try to have an intuitive understanding of what exactly this means, right? So, agent is nothing but a digital worker. Yeah, imagine it as a digital worker. What a human can do, a digital worker can do, and that's where we are talking about how AI will augment humans or replace humans in some of the other tasks, right? So, who is the best agent? What do you think the definition of best agent would be? So basically, when we talk about agent, right? What is a best agent, right? Let's define first best agent. Best agent is the agent who can perform task with minimal resources, right? Now the best agent till today, if I call human also as a machine, it's human. So whatever human does with minimal resources, no other machine in the world can do, right? So human is the best agent. If I compare and if I say human is also a machine, human is the best agent. And still we are talking about that humans will be replaced by agents, AI agents, and we will maybe augmented by agents. We do will not need so many humans to perform certain types of tasks. So why are we saying that? When I say human is the best agent, and still at the same time we are talking about that many tasks would be replaced by humans. Digital agents. So why are we saying that? Anybody can think of this? So basically, when we do apple to apple comparison, right? So when we are comparing human as a stand-alone entity and using its own resources to perform a task, then human is the most efficient agent. But as soon as when humans start using tools, like for example, if I am doing using Excel to perform calculations, or if I am using presentation, like I am right now using presentation to present my topic, right? As soon as you start using external tools, inefficiency kicks in, right? If I am only giving presentation on my own, using my own resources, my hands, my voice, my gestures, then I'm the most efficient agent, right? As soon as we start using external tools, that's where inefficiency pops in. And how it relates to a business problem, like when you're solving business problem, you use a lot of tools, right? I use Excel, I use presentations, I use Word documents, I use ANSYS software or Fluent software for computational fluid dynamics. That's where inefficiency kicks in, and where that's where we start comparing it with a digital worker, which is AI. Can AI reduce that inefficiency? And if it reduces that inefficiency, then definitely AI would be preferred more over an human, right? So it becomes an underlying framework, right? Where human is adding more value in the context of whole ecosystem, those tasks will not be replaced by AI. But if AI is adding more value in the context of all the tools used, all the peripherals used, then those tasks will be replaced by AI. And we'll talk more about this when we go forward. It was very important to define this upfront, because then this is going to be used to understand where AI to be used, where AI not to be used, and how sustainability plays a role even defining this, where AI to be used and where AI should not be used. So that's why it was important to define agent. Again, we'll come to this agent definition later as well, but that's why I started with what is agent and who is the best agent, right? Now, before we get into, again, as I said, before we get into sustainability, I would like to give a background of AI, ML, so that you understand when we talk about sustainability, or when we try assess AI solutions from a point of view of sustainability, what things we should look at. And this would be possible only if we have some background of it. Now, many of you might already have the background of it, and many of you might not have it. So I have kept it to really take into account the context of, we have different type of people on this call. I have introduce this section as well, where I'll give you a little background of AI ML, so that you understand it from a sustainability standpoint, sustainability perspective later, right? So there are three different types of personas when we talk about AI, or rather we talk about any technology, right? There is a research persona who are actually building or who are actually doing research in AI. So for example, the people who have built LLMs, or the people who have written papers like Attention is All You Need, the transformer paper on which all these LLMs are built. right? LLMs are nothing but large language models. You might already be aware of. So LLMs are nothing but large language models. So there are three different types of persona. One is the people who fall into research category, who are actually building these amazing models, which are coming from OpenAI, Anthropic, and Google's of the world. And there are algorithms coming in ML space like random forest model or gradient boosting model, or neural network model. So this is all falls into research category, where all these research folks are actually supplying this technology to us, right? Now, then second category is the application category, where most of us will lie, right? There would be many people who will fall into the first category. The second category, again, in the second category also research exists. Only thing is it is applied research, right? Where we will take these amazing models or amazing algorithms and will convert that to some sort of application or utility, which is good for business or which is good for humanity or which is good for society, right? So second category is the application developer who will take all this amazing research which has already been built and convert that to an useful utility or an application, right? So that's the second persona, and majority of the people falls into this. Third, definitely the user of these solutions, the consumption, basically the consumer of this solution, AI solutions. And today we all are basically user of AI, some or the other way, right? When you're buying something on Amazon, seeing your buying pattern, it recommends you things, right? That's AI running behind it. AI-based recommendation engines running behind it. Then whether you're browsing on internet, right? If you're doing Google search nowadays, you might do Chat GPT or anything, right? If you're browsing on web, you will see a lot of advertisements depending on what web page you are in. So that's also there is a profiling engine running behind which understands your persona and accordingly recommends you the stuff that you generally look at, right? So in some or the other way, you are anyway already consuming some AI based application today. So it is very important to understand these personas because each of these persona has some responsibility when it comes to deploying AI solutions, whether for business purposes or whether for the society, right? In research persona also there are a lot of things you can do to reduce the impact of energy consumption when we are applying AI for any problem statement, or to reduce the impact on climate when we are using AI. So each of these persona we have some responsibility, though the end user really don't bother about it. Like for example, uh, I'll just give you a crude example, right? You might have heard about Zeptos and Instamart of the world. I am in Bangalore. Here it is very prevalent, right? You get 10-minute delivery. Now, do you really need 10-minute delivery? That could be debatable, right? But because of convenience, people tend to adopt it, and it is being used. It is doing very well in Bangalore, at least I know, because I am in Bangalore, so I know about Bangalore. But in other parts of the country also, it might be flourishing, right? But when I'm asking for a 10-minute delivery, think about the supply chain and think about the things which are running at the back end, right? Now, I'm not against Zeptos and Instamart of the world. They are doing well because people are demanding for it, right? There is a demand in market, and that's why they are doing well. But I'm saying from a consumer standpoint, generally it is not taken care of, because if there is something which is of your convenience, you will end up anyway consuming it, right? But from a research and application standpoint, definitely if I design my systems, keeping in mind the sustainability and the energy consumption aspect of it, other than the business aspect, definitely business aspect will also come into play, because if it is not making sense from a business standpoint, I'm not going to build that application. But if you take into account even the sustainability aspect while designing this AI solution, automatically your solution becomes wholesome and it becomes much more efficient and sustainable for long term, right? And that we are going to see when we talk about applications also. So far, so good. And guys, I don't want to give a monologue. If you have any questions in between, feel free to ask. I am happy to answer, right? And you can ask something which is related to stuff which I'm talking about, right? So don't shy away from asking questions in between. Okay. So we define personas, right? There are three types of personas. Now, when we are talking about LLM, why we are discussing about ML? Because when we talk about LLM, what is LLM? LLM is a large language model. right? And those who are actually studying about large language model, they would know that large language model is built on a lot of unstructured data available in space, including structured data. But it is a language model. And why it is called a language model and why not? So my question is, can you build large language model on tabular data? Like, for example, if I have a data in Excel, wherein I have multiple columns, and then I have a target column, for example, right? So maybe imagine I am trying to predict uh, uh, loading on a boiler, right? And I have historical load patterns for a plant which have deployed a boiler or installed a boiler. And I'm trying to predict a load pattern of a boiler based on the historical data available. And I have a target variable, and then I have several columns before the target variable. So can I build a large language model taking into account one boiler plant readings, which will be applicable for either boiler plant readings? Can I do that? Anybody? So we cannot do that, right? Why? Because the conditions at one plant can be very different from the conditions at other plants. And the variables that we are using in one boiler, for example, here I am running a boiler which is fed with coal as a fuel, right? And then there is another plant which is running on heavy oil or light diesel. So there could be very different conditions, even in terms of environment, in terms of fuel, in terms of loading patterns. So that's why you cannot build large language model only on tabular data. And there is a very good intuitive understanding behind it also. When we built large language model for, say, language, English language or Hindi language or Marathi language has a underlying superstructure. Like, for example, there is a particular grammatical structure for any language. When we talk about English, right, it has a way of arranging the sequence of words like subject, predicate, subject, verb, predicate. Similarly, when we talk about in Hindi, it has a structure defined. When we talk about Marathi, it has a structure defined. So there is always a superstructure. Even vision is a language, right? When we are seeing something and we are trying to understand it, it's a visual language, right? So whenever there is a superstructure which we can train on, like for example in vision, essentially what our mind does at the back end is it breaks down that particular image into multiple components and then try to understand each object separately. We need not to get into dynamics of how image processing happens, but what I'm saying is if there is an underlying superstructure which is general, like for example, if I'm trying to learn English, there is a superstructure which is valid for every English sentence, right? There is a way in which English sentence is organized. So that's why LLM exists for unstructured data, but it cannot be trained on tabular data because the conditions that you're talking about will be differ from each other. And then there is a new condition which will come. Like for example, even the arrangement can change. So imagine same data, right, which I was talking about, boiler data. If I have last column as boiler load pattern and the other column says, like for example, there are 4 columns. First is pressure. Let me write it, right? First is say pressure. Second is temperature. And third is load, right? Now, even if I change temperature here and pressure here, it doesn't matter, right? Tabular data does not have any impact. Still, I can build a model y is a function of x1, x2, right? It doesn't matter here. So what I'm essentially saying, there is a no superstructure here, which is always common across different problems. But when we talk about language, there is a superstructure which helps you build this large language model, which is in generic in nature. And as soon as you start asking question to large language model, it can respond to your questions. So now, though we have established that, like you might have also read about it, right? ChatGPT sometimes is very bad at mathematics, even school level mathematics. And not only ChatGPT, basically LLMs are not very good at sometimes very simple problems, but sometimes they can solve even a PhD level problem. Why is that? Because LLM inherently is trained on unstructured data. To handle structured data, it needs tools, right? Like for example, similar to us, right? I started with which is the best agent, right? Human also to solve problems, we need tools, right? We need some mathematical tools. We need maybe even physical tools, right? To solve problem in physical space. So we need tools. Similarly, LLMs also needs tools. And one of the tool which LLM needs is ML, machine learning, other than the other tools like data tools, data science tools, where LLM start becoming efficient and efficient. Like new age LLM, they're all developed to call these tools. We'll talk about these tools, right? How they are called, and why it is important to know this aspect of when we are using LLMs. Then only we'll be able to understand why a particular use case can be solved using AI and LLM, and another use case does not require LLMs or AI. Better to keep with, better to solve that use case using our fundamental knowledge and keep human as the most important factor in solving such problems. So this is very important to understand before even we start understanding how sustainability should be accounted for, how sustainability should be, how we can how we can resolve the problem of sustainability, right? Now coming back to ML. There are three types of ML or machine learning problems, and there are multiple subtypes also, but these are the three fundamental types. One is supervised machine learning, second is unsupervised machine learning, and third is reinforcement learning. So what is supervised learning? Supervised learning is basically, imagine if I have given you 100 images of a car and I have labeled each image with the brand of a car. So for example, I gave you 10 images of Toyota, 20 images of Mercedes, 30 images of Maruti, 40 images of some other Skoda, some other brand, right? So I have given you labeled images, and then now I will give you a new image and I'll ask you to predict what brand this particular image belongs to, right? So that's supervised learning, where I am giving you labeled data, where I am not only giving you a data point, which is an image in this case. You can have structured data as well, tabular data. I'm just giving you an example of supervised learning. So I have given you images, which is independent data set. In regression world, you have dependent variable and independent variable. Here, independent variable are images, and the dependent variable are the labels, right? So if I give you labels along with the independent variables, which are images in this case, then it's called supervised learning, where I already know the target which I am looking for. Unsupervised learning, the name itself suggests you don't have labels. Now let's take the same example. You have 100 images, and I don't give you any label for those images. Images of a car, and I ask you to run unsupervised model on those 100 images. What will happen then? So unsupervised model, one of the most widely used model is clustering model, right? There are different types of clustering model, k-means and different types of models. So clustering is what? It will take different similar characteristic images and put it into one bucket. So for example, if I have 100 images, maybe it will create 4 buckets. One bucket of all green cars with less than 4 meter length, right? The second bucket would be all 7-seater cars with length of car more than 4 meters. So what it does is it understands the underlying characteristics in the data, and it tries to calculate the distance between these characteristics, and which are closer in terms of characteristics, it will put into one bucket. That's unsupervised learning. You don't have labeled data, so it tries to identify similar characteristics and put that into one bucket or one cluster. So that's unsupervised learning without labeled data. And third is reinforcement learning, which is very similar to how we humans learn anything, right? So in reinforcement learning, there are 4 very important components. One is action, one is actor, one is reward function, and third is the feedback loop. Or rather, the fourth is environment. Actor, action, reward function, and environment. Now imagine I have a 5-year-old at my home, right? So imagine this world is an environment and my child is an actor and he does some action. Now, if I scold him, which is a negative reward function, then he knows that this should not be repeated. And if I give, say, chocolate to him on doing something very good, then he knows this is a very good thing to do and he'll keep on repeating these things. So reinforcement learning exactly works on this particular phenomena or a particular algorithm wherein there is an actor which performs an action and there is a reward function. It can be a negative reward, it can be a positive reward. Negative reward is nothing but a penalty. And based on that, whether if you get a penalty, it understands. The model understands that this action is not in line with what our objective is. And the second action where you get a reward, higher reward, it understands that this action is in line with my final objective. And that's how the algorithm runs. And the environment is basically the constraint environment. So for example, you might have read about this news that a long time back, right? The IBM had beaten the world number 1 in Go game, a game called Go. So this was trained using reinforcement learning. So for example, if you are making robot learn chess, So chess is a very constrained environment. You have 64 boxes, you have 16 pieces on either side, and every piece has a particular way of moving, right? It has to move in a certain way. It cannot, like, for example, your king cannot move like your queen cannot move. Sorry, king cannot move like queen, right? So there is a particular constrained environment. When you have a constrained environment, reinforcement learning is the best model to be used, right? But when we talk about world, right, which is very open ended, that time applying reinforcement learning on actual natural problems or business problems becomes difficult, and that's where supervised and unsupervised learning comes into play. Else, if you have a constrained environment which you can define and where you can define the reward function, reinforcement learning is the best way to go forward, right? So these are the different types of ML we use, and then for each ML there is a different metric to understand whether this model is good or not. That's where we come to practical aspect of it. This is where we come to practical aspect. Now I'll talk about two problems and you guys have to speak about it. So I'll talk about two problems. One is everybody have a phone right nowadays, and most of the phones will have face recognition system, right? Either face recognition system or fingerprint recognition system, right? Either of this is available in each of the smartphones today, and most of you would have either of these definitely. So I want to understand. First, let's take this problem of face recognition system on mobile, and then we'll talk about a manufacturing problem, right? Here, I want you to think about it and tell me an answer whether false positives are allowed in face recognition systems or false negatives are allowed. And to understand that, first I need to define what are false positives and false negatives, right? So false positives are nothing but false accepts. False accepts means you are accepting something which you should not have accepted. That is false positive. And false negative is false rejects. That means you are rejecting something which you should not have rejected. Did you get it? False positive is something which you are accepting, which you should not have accepted. False negative is something which you rejected, which you should not have rejected. Right? Now, when I'm designing a face recognition system of a mobile, you need not to know how that is designed. But from a metric standpoint, can I allow false positives or can I allow false negatives? Anybody? See,
False
50% chance
positive
of being
cannot
right.
be false
Yeah.
positive cannot be allowed.
Why is that?
Otherwise, any person can enter the system.
Correct. Correct. Absolutely correct. So you should not accept which you should not have accepted. Like, for example, if I am seeing my phone, it should be open. But if someone else is seeing my phone, it should not open, right? With someone else's face. So false positives are not allowed. Now, why this is important? Because as soon as you know that this metric is the most important metric, you should not allow false positives, but you can allow false negatives. And this you see many times in your phone as well. Like sometimes it is not able to recognize your phone because of n number of reasons. That time you have an alternative mechanism where you can enter your 6-digit password and get in, or 4-digit or 6-digit password to get in, right? So that is a backup mechanism where human in the loop comes into play. But that is false negative because it missed recognizing your face, but that is okay. But it should not recognize someone else as you. Else, it would be a security problem, right? They would end up entering your mobile phone and can do whatever they want to, right? So that's why this problem should not allow false positives. And even though it looks trivial, this is very important to understand because as soon as you understand your metric, your system design becomes easy. What is the system design? System design, one of the most important aspect is when do you introduce human in the loop, right? Like for example, here, when I have a false negative where my phone, I was not able to recognize, my phone was not able to recognize my face. I have an alternative mechanism where I can manually enter those 6 digits and get enter into my phone, right? So that is system design. So here, one of the most important part you should understand is in whether it is ML problem or whether it is LLM problem. These are all probabilistic based models, right? They cannot be 100% accurate. So are we going to wait till this model get 100% accurate? That is not going to come. It's theoretical. Probability cannot be one, right? You guys are professors, so you know this. So you cannot have 100% accuracy. But then, do you need to wait till you get the 100% accuracy? No. That's where system design comes into play. You should understand your business problem and accordingly you should design your system. So that's why to understand and define your problem in right way, it is very important to define the metric first. That's why this face recognition problem I talked about. Now let's go to the second problem. Now, because we have talked about false positives not allowed, naturally I'll give you an example of false negatives not allowed, but you should tell me now why it is not allowed, right? So the problem statement is I have a manufacturing component line where I am doing visual inspection, right? Now I have to either augment or replace my visual inspection by computer vision based inspection, basically AI based inspection, which will tell me whether this particular component is defective or not defective, right? Now, I am saying here false negatives are not allowed. Why is that? From a system design standpoint, how do I elaborate on this? False negatives are not allowed. Like false negatives are nothing but I don't want to reject something which was not supposed to be rejected, right? False negatives is false rejects. False positives was false accepts. I don't want to accept something which should not have been accepted. False negatives is I should not have rejected something which should not have been rejected. So here false negative should not be allowed in this problem statement. What is the problem statement? I have a manufacturing component line wherein I want to convert or rather augment human-based visual inspection with AI-based visual inspection. And I am saying here false negative should not be allowed. Why is that? Think of it from a human in the loop perspective, whether human will come first or AI will come first. And that way you will be able to think through why false negative is not allowed. Anybody? Maybe someone can try. See, now what is our problem statement? Our problem statement is to identify. Imagine I am an AI model now, and my objective is to identify which are the defective pieces or which are the non-defective pieces, right? The filter between the defective and non-defective pieces, right? Now, imagine if I reject and my solution design is my AI is sitting first, followed by a human, right? First, AI filters out most of the pieces, and then human only caters to the remaining pieces. Why human cannot be before AI? Because if you put human before AI, then human is already taking care of all the pieces which he or she was taking care of earlier also, right? Then there is no use of AI. So human will sit after AI. Now, as AI is sitting before, if AI rejects one of the defective piece, right? What will happen? That defective piece will end up in my customer hand, which I don't want, right? But if I have false positives, that means even if there is a piece which is not defective, and if I, as an AI, if I identify that as a defective, that is okay. There is a human sitting behind me who is going to filter out those edge cases, right? So in this case, false negatives are not allowed. Did you get this? Once you understand this aspect of it, you understand the system design and you understand the role of human in the overall design of a particular solution, whether it's a business solution, whether it's a domain solution, whether it's a science solution. This is very important to understand because you will never get 100%. There are few rules you should always be aware of. You cannot get 100% accuracy. Second is defining the problem. And third is defining the right metric for that problem. Because if you define the right metric for that problem, you are already taken care of how your system design will look like. So that's why to understand these things, it is very important to understand how you should define a metric, right? And most of the problems in the world will fall into supervised or unsupervised learning. Unsupervised learning, you don't have labels, so there is no false positives or false negatives. It's a different class of problems. But most of your problems will fall into supervised learning problem. That's where your prediction starts, right? Because you always have an objective which you are working towards. So supervised falls into those categories. And most of your problems will again fall into whether you can eliminate false positives or you have to eliminate false negatives. Like for example, fraud detection system, right? In fraud detection system also, I cannot allow false negatives. Why? Because even if my AI miss one fraud, my one fraud can run into millions, right? So I should not allow false negatives at all. Right? So there is always one of these metrics. Either you have to reduce or eliminate false positives or eliminate false negatives. Once you understand this, you will understand where my human will play a role or where human will play a role overall scheme of things. And once you know that, then you can define the effort consumption in that particular solution. And if you can define the effort consumption in the solution, you can define the energy consumption in that solution or energy spent in that solution. Once you understand the energy spent in the solution, you can even optimize for energy. That's where your sustainability factor also comes in. Any question till now? Because this is very important. Before we get into some information-based slides, definitely I don't want to give more information. I want to give you more thought process around how these systems work and how you should think about when you get into, any of you get into this research around LLMs, AI, or sustainability in the era of LLMs. If you get into all these aspects, you should have your own thought process around it, intuitive understanding around it. Then only you'll be able to define the problem correctly. I'm not saying many of you might already have this understanding, but this is what our goal is today. Any questions till now? Feel free to ask questions. That will be better, right? So why LLMs on unstructured data, which I already answered, right? There is something called superstructure. Again, superstructure is not a technical word. It is more to have an intuitive understanding where you have something which you can generalize. Like in language, you have a grammatical structure which you can generalize. And that's why wherever you have something you can generalize across different class of problems and across domain, building a pre-trained model, which is a large language model in this case, makes sense. If you cannot generalize across use cases, why to build a generalized model anyway? You have to train it for new data, right? So that's where you should think about where LLM would be required and where LLM should be used, where LLM cannot be used. It will help you understand thoroughly when you are defining a problem. Now, getting into little details of LLMs, right? First, before we get into contextual limitation, let's talk about small versus large LLMs. Where do we need small language models and where do we need large language models? You would see in the market, right? Every other company is releasing different sizes of model. There are few 70 billion, even 600 billion parameter models also. And there are even 8 billion, 3 billion, even now 1 billion parameter models and even million parameter models also. But every model is useful. It's not like big models are not useful or small model is not useful. So each one of them have a different role to play. Can somebody tell me where small language models generally fail and large language models are definitely required? Any case which you can think of that this is the case where small language model will not be able to catch up any time with large language model. See, if you see the journey from where the ChatGPT released, even before ChatGPT released, there was large language models because ChatGPT released when OpenAI came up with GPT 3.5. But before GPT 3.5, there was GPT-1, GPT-2, GPT-3 also, right? Only thing is ChatGPT, when ChatGPT came, it became so easy to use for end user. That's why it got famous, right? What I am essentially saying is we started with bigger models and now even smaller models are as good as bigger models. But they are good in some aspects, but they are not good in some other aspects. And one aspect they will never be good at, like what a large language model will be good at. What is that aspect? Can anybody think of? Think about memory, right? Imagine if you have an infinite memory versus imagine if you have finite memory. What is the advantage of having infinite memory? Anybody? I hope you guys are understanding something, right? Or am I only giving a monologue? Anybody? I hope this is not too late. You guys are awake. Even I have to keep myself awake. No one? Okay, so see, the difference between infinite memory and finite memory, right? So large language model will always have more knowledge incorporated in the parameters of that model. Why is that? Very obvious, right? So for example, you can dump in the knowledge of civil engineering, mechanical engineering, computer science engineering, even artistic domain, all the possible domains in the world you can dump in and it can learn about each and every domain that is out there in the world, right? Can you compress that language in one form and dump it in small language model? It is not possible because more the memory, more the knowledge or more the information you can store. lesser the memory, less information you can store. So when it comes to domain knowledge, your large language model will always have a better domain knowledge. So what's generally what people talk about is fine tuning smaller model for your given domain. Because if you want to use smaller model for your domain, then you want to train that model on your domain so that you end up using a smaller size model and hence smaller cost, smaller energy, lesser energy consumption, and still you can go ahead with that. But large language model will have cross domain knowledge also, because like for example today, if you are doing research in say mechanical engineering, right, you cannot avoid fundamentals of civil engineering or any electronics engineering, or if you are doing research in AI, you cannot even avoid the fundamentals of mechanical engineering. I'll give an example of how I have used mechanical engineering fundamentals to solve banking problems. I used to work for 10 years in Thermax, and then I start applying AI for banking. I have used a lot of my fundamentals which I used to use in mechanical engineering into banking problems. So if any model or if any human have cross-domain knowledge, it is always good to have that knowledge, because then you can apply the learnings of one field into another field, right? So difference between small and large LLMs is, if you want to leverage cross-domain knowledge or the domain knowledge itself, then large language models will always be better than smaller models. If you are building an application for one task, like for example, if my objective is to extract information from documents, right? So only if this is the task which I want to perform, maybe I'll use small language models. And there are many tasks which a small language model can do. But if you want to do something cutting edge, or if you want to do something which is related to domain knowledge, better to go with large language models. So again, why this aspect is important when we are talking about sustainability, because once you understand what type of problem you are solving, you will use the right size of the model. Using right size of the model automatically optimizes the energy consumption, because to infer from large language model the type of GPU that is used, and GPU is very energy, it consumes energy n times more than a CPU can consume, a CPU consumes, right? So if your problem statement requires large language model, then only you should use large language model. And you can even optimize between small and large language model. Like for example, within a problem statement, for one task you are using small language model, but for verification you are using large language model. Something like that from a design standpoint you can understand. That's why very important to understand what are the limitations of small language models and what are the strengths of large language model. Then only you'll be able to design the system accordingly, so that you reduce the effort spent, energy spent, money spent on your underlying problem or underlying objective that you're trying to achieve, right? That's why it is very important too. So coming back to cross domain, right? Why it is important? So again, this is one of the examples where we were building a recommendation engine for corporate banking, right? Now in corporate banking, again, you need not to know banking for this. Just try to understand from a problem statement standpoint. In corporate banking, the way product is purchased is, sometimes it is purchased in January, then maybe in March, and then maybe in November, sometimes maybe in April. So it is very time inconsistent, right? Now we were debating about how do we define this problem in terms of times, right? Because it is a very time inconsistent problem. So how do you even formulate this problem in terms of time, right? Then what we have studied in fluid mechanics, right? We have something called Eulerian principle. Some guys would say Eulerian principle or Lagrangian principle. In Eulerian principle, you are sitting at one place and you are seeing a particle moving, and the way you write your equation is deba by deba t, right? And when you are using Lagrangian principles, you are actually moving behind a particle, or you are sitting on top of the particle and you are writing your equations. So you are writing equation in terms of state domain. So if I leverage this understanding of state domain and time domain into my corporate banking recommendation engine problem, basically when a product is purchased, and even though I'm talking about corporate banking, you can relate it to even your Amazon recommendation engine. It is not about whether I'm buying this product in January or February. It is basically the state at which that product is purchased. For example, as an organization, if I'm buying that banking product, it all depends on what is the market scenario, what is my current state. And when I say current state, it is basically what is my revenue today, what are my margins today, how is the market outlook. This is the current state which is leading to that product purchase. So the way you need to formulate this problem is in the state domain, not in the time domain. Now we have learned this in our fluid mechanics principles. right? You can definitely apply into banking recommendation engine problem. So that's where cross domain helps. Why large language models will have a very important role to play is because you can now leverage cross domain. Maybe you are expert of mechanical engineering and you're not expert of some other form of engineering, but still you can leverage large language models to combine the knowledge of the two and come up with some very uh, amazing solutions out there, right? So that's why it is very important to understand the limitations and the strengths of both small and large language models. Again, feel free to interrupt wherever you have any questions, or else I'll keep on talking, right? Now, the third aspect, right? We talked about what is an LLM and why LLMs are only on unstructured data, why not on structured data. And when I say not on structured data, definitely there is a lot of structured data also gone into LLM. What I'm saying is only on structured data, it is not, we should not train it, like, for example, tabular data in specific, because there is no superstructure involved there. But in unstructured data, wherever there is a superstructure which can generalize across different class of problems, you can train an LLM. Then we learned about small versus large language model, why it is again important to understand small versus large language model and why LLM cannot be trained on structured data, basically to understand what type of solution I should apply for a given business problem. If it does not require LLM, I should not unnecessarily boil down the ocean and say LLM se main sab kuch kar dunga, right? You should not do that. Maybe a simple ML solution or even maybe a logistic regression or linear regression problem can solve your problem. So you should not unnecessarily complicate the solution. Similarly, small versus large language model, why it is important to understand? Because few problem statement would not require large language models. So as soon as you use small language models, your investment on that particular problem statement or the solution goes automatically becomes less, right? And when it is less means it is less in terms of money, it is less in terms of energy consumption. When it is less in terms of energy consumption, automatically you're taken care of sustainability. And your solution also will be sustainable. And from an environment standpoint also, it would be a great design to have. So that's why it is very important to understand all these aspects of when you're defining a problem and where you're trying to solve a problem. Now, the third aspect, right? Context limitations. Now, what is a context limitation, right? Now, if you remember, I don't know how many of you use ChatGPT, or mostly you might be using ChatGPT or for some or the other purposes. When we started, or when large language model was first came in the form of ChatGPT, the context length which it can understand was very less, right? Like even today, there are embedding models which have a context length of 512 tokens. Tokens are very equivalent to word, basically. So what we are saying when we say context length is basically it can understand so much of context only. If we throw something more than this context, then your LLM will not respond efficiently or effectively. So for example, if one LLM has a context length of say 500 words, generally it is measured in terms of tokens, but we'll say words for the sake of understanding. So you can put in only 500 words along with your question. If you put in something more than that, then it will not be able to understand. So basically when we say context, your LLM has an ability to understand only 500 words. If anything goes more than that, then it is not able to comprehend more than that. And if it is not able to comprehend, the answer would not be that efficient or effective or correct, because it is outside the context length of LLM. Now, when a first model came versus what the models are capable of today, like for example, Gemini models from Google can go to context length of 2 million tokens now. Now, 2 million tokens is huge context. It is more than a book you can feed in and still it can understand, right? But more the context, when you feed it into an LLM, it consumes more energy. Why? Because say, for example, if you're feeding a complete book into LLM to get one answer, which is maybe at, say, for example, it's a 200-page book and your answer lies at the 10th page. That's it. You need not to refer to all the 200 pages. And if your design is you're feeding the whole book just to get one answer from one page, it's a bad design. Why bad design? First is your GPU requirement will be very high. Why your GPU requirement will be very high? Because you're feeding 200 pages directly into memory. GPU is nothing but a memory only, right? You're feeding all 200 pages into memory. It will consume more energy and more GPU, and your solution is not sustainable, sometimes not even sustainable from an ROI perspective also, from a business perspective also, right? So that's where context limitation also play into role. It's not only about LLM context limitations. It's also about from a design standpoint. So the first part which I explained was architectural limitations, wherein LLM got improved over a period of time, wherein initial models were able to understand very less context. Nowadays, model can understand up to even 2 million tokens or 2 million words. Now, from a design standpoint, to come across or to solve this limitation, what we do is we use something called RAG. RAG is nothing but retrieval augmented generative engine, RAG engine, we'll say, right? Now, you need not to worry about these technical jargons, right? Basically, RAG engine is nothing but even before feeding that information to LLM, what we do is we first find out which context will have that answer, where we can apply simple search. Like, for example, even keyword search will play a role. Say, for example, I have a 200-page book and I just want to extract the author name. Who is the author is my question, right? So, what I will do is I'll search for an author wherever the author word is present. Maybe I'll select only the top 10 pages where the author name is present, including maybe the first page. And then that information only I'll feed into LLM. Now, what I'm doing essentially here is I am restricting and I'm trying to simplify, right? It's not a very straightforward. It's not always keyword based search. It can be even semantic search, but we need not to get into nitty gritties of how RAGs are designed for LLMs in this topic. If you need sometimes someday we can talk about details in LLM, how you design RAG and all that. But right now it's an intuitive understanding. Basically, what we are essentially doing is instead of feeding 200 pages directly to LLM, what we are doing is using this RAG engine, we are feeding only 10 pages now. And still it is able to answer my question, which was who is the author. Now, what I am doing is I am reducing the GPU load and hence I am reducing the energy consumption. So from a designer standpoint also, it's not only the duty of LLM providers, it's also the duty of application developers to design that system which is sustainable, both from a business perspective and also from an energy consumption perspective. You are with me? So context limitations have both aspects. One is design aspect, which we can take care of. One is architectural aspect, which researchers can take aspect of, which I talked about persona in my first slide itself, right? Is the second slide. There is a research persona who are taking care of LLMs, how much context they can handle, right? So that they are taking care of context handling from a architectural perspective. But from a design perspective, when I am building application using LLM, I also have my a duty, or I can also add my value by designing a efficient RAG system before I feed a context into LLM that will reduce my GPU requirement to a drastically reduced level, and hence the energy consumption would be very less, or the money spent would be very less on GPU, and hence the ROI will be more, right? You are with me, guys? Okay, so these slides are over. I have one more presentation for you, but before I move to the presentation which is dedicated on sustainability, even though this had the aspect of sustainability, but this background was important so that you could understand the importance of what I'm going to talk about in sustainability slides also, right? Any questions before we move on to the second part? Anybody? Any question? Anybody? I know this is 9 o'clock even for me also. Speaking continuously at this hour is little tricky. So you guys need to help me out. Anybody? No? Hope I am not boring you guys at 9 o'clock, 9 p.m. Okay, chalo. So let's get to the last aspect of it. And I'll run through the slides very quickly so that we'll have some time for question and answers, which is important from my standpoint. So when intelligence consume power, this is our topic, right? Now, what I'm going to walk you through is some aspect from a supplier standpoint, right? How the systems are even designed today uh, to reduce the energy consumption, and there are different aspects to it, right? And I'm going to share these slides. The earlier slide has nothing; they are only bullet points. But this slides or this HTML has this information also about each slide. So I'm going to share this later. If someone wants to refer to, they can refer to. Okay, so my first question is breaking common assumptions. I'll start with question. I started with question there also. Who is the agent? Now here, which dominates lifetime energy footprint? Training of the model efficiently, or inference from the model efficiently, what will drive the lifetime energy footprint reduction? This is now easy one, very obvious one. What do you think, guys? Anybody? Sorry, I could not hear you, Dr. Imanshi. Okay, so it's basically inference, right? Inference will drive if you reduce the or if you increase the efficiency of inference, because training is one time, right? You're training a model and that's it. Now you are going to use this model for n number of times. Like for example, if OpenAI might not have moved from even GPT 3.5 to GPT 5 today, still GPT 3.5 would have been used forever, right? As a chat GPT. So inference is forever. So if you design your system on efficient inference, it is going to reduce your energy footprint forever. So that's why it is very important to work on inference also. And why this is very important to understand is, many people talk about if we build a, and it is not only talk about, you will find that in research, if you try to do research on web also, that training an LLM in India is leads to higher energy footprint or higher carbon footprint. Why is that? Anybody? If it versus training an LLM in say Europe or maybe in USA, training an LLM in India will lead to higher carbon footprint. Why is that? Come on, anybody from mechanical engineering or any other engineering for that matter. So basically in India, the major source of electricity till today is coal, right? So, and then followed by whatever the sources of fuel, right? So the cleaner is the source, because when you try to train a large language model, you are consuming lot of energy or electricity. So if your source is not cleaner, naturally your carbon footprint is going to be higher. Versus if you are training an LLM in Europe where maybe majority is coming from say renewables or some cleaner source of energies. For example, if you move to US, majority coming from say natural gas, right? Here, majority of the electricity is coming from coal. So your carbon footprint is going to be high. But should that stop us from building an LLM? No, because again, to our first question, right? Inference is what matters, right? So if we find out a way wherein my model is so efficient that during inference time, it is going to consume less energy, definitely we should build it, right? So this is the first part you should understand, which is also very important. That inference, building a right design during inference is very important. Instead of trying to spend time, definitely during training time also, if you spend time to reduce energy consumption, well and good. But that is one time. Remember, inference is forever. So you should spend more time while designing the system, and then that becomes the responsibility again on the application engineer persona, because people who are doing research are going to build LLM one time and give it to you. Now it is your job to take those LLMs and convert that to a right utility with lesser energy consumption. So that's why this question is important. Now the second question, what reduces energy per answer most effectively? Whether it is batching plus smart routing. Now it is not very obvious, but still if someone wants to try, larger models, more GPUs, obviously larger models and more GPUs is not the answer. Prompt engineering to a certain extent, it will help. Now imagine, right, when you're building any science application, domain application, or a business application, it should be agnostic of expertise on prompt engineering, right? Like for example, if I'm going good in asking question, then only it will perform well. And someone if is not very good in writing prompts, it is not well. That's not how application works, right? Application is always agnostic of the capability of the user. Definitely, not completely agnostic. Like for example, if I don't know how to use CFD tool like ANSYS or Fluent, I'll not be able to use. So it is dependent on users' capability. But in general, I'm saying it should be from an outcome perspective, it should be deterministic. Even though we are building a probabilistic based application, it should be deterministic. So that's why better answer is batching plus smart routing. Now, why batching plus smart routing? Batching is basically you are trying to do job in parallel. Smart routing is basically you're routing your prompt through combination of models. Like for example, if your prompt requires smaller model can answer better to your prompt, why to go for bigger model? So that's smart routing. So that's why again, from a design standpoint or from an application engineer persona, it is important to spend time on smart routing and batching, which will effectively reduce your energy consumption. Okay. Okay. Now the second myth, box that multiplies answers. Now what is happening nowadays is your smaller models are becoming better and better. And there is something called quantization. Quantization is nothing but, in intuitive terms, you're trying to compress the model into smaller size, the bigger model into smaller size, without compromising too much on accuracy, right? Now, what does that mean is, even we can use LLMs on our laptops, right, today. So, making model very efficient, is it reducing the energy consumption? No. This is called J1's paradox, wherein, because efficiency improvement will lead to more usage, right? More people will start using it. Maybe sometimes you'll start using for something where it is not required also. So what happens is, as soon as things start becoming efficient, it does not, from an wholesome perspective, right? Effectively for each task, you have reduced the energy. But now what has happened is, people are using for each and every task, right? Even for smaller problems where AI is not required, LLM is not required, people will tend to use there also. So that's why this is called Jevons paradox, wherein efficiency improvements often lead to increased total consumption. So this is why this is again important. This is more from a framing perspective, right? The policy people perspective. When people make policies, sometimes maybe policy would come that this type of problem should not be addressed through AI. You never know, right? Because as soon as AI start penetrating into each and every field, the energy demand is going to increase for these models and the usage of these models. You will see a lot of policies coming in the next few years around this. Already people are working on it, and they are revising policy each and every year from a regulatory, from a data privacy standpoint, and also from a sustainability standpoint. Those who are eager to know about sustainability related policies, they can really read about policy documents or the frameworks from European countries, right? They are very much into this space, wherein they talk about the importance of energy consumption compared to US. US is more innovation pro, so that's why they don't constrain people to try it out. But Europe is more sustainability pro, so you will see a lot of sustainability related practices in European regulations document, right? Those who are interested, they can go through that. But what essentially we are talking on this slide is that making LLM efficient is not going to reduce the energy consumption in the wholesome, because more efficient it becomes, more widely it will get adopted, and sometimes it will get adapted for not the task which does not require AI also, which you would might already be seeing in your day-to-day life also, right? Maybe some people are getting so used to writing emails using ChatGPT that even though if 2-3 lines email they want to write, which they could have written very easily, people take help of ChatGPT, right? So I'm just giving you one trivial example. This will happen for many other tasks as well. Now, where should we answer? Now, this is also very important to understand, right? To run an LLM, even though we are not seeing an LLM when we are asking something on ChatGPT or any other platform, Gemini or Anthropic, but there is an LLM running somewhere, right? And there is a data center which is running that LLM. So the location of that data center is very important. Now, from those who are heat transfer experts, right? They would know. So, for example, the areas which are more humid, evaporative cooling would be more effective, right? Similarly, the windy areas, so we have different climatic conditions around the year, right? So depending on, and we can have data centers at different locations. So depending on time of the year or depending on the location of the data center, the energy consumption would vary. So this is very important to understand from a data center deployment perspective, where your data center should be located, right? You should not just choose a area which is very dry and then try to do evaporative cooling in those areas, right? It will be very less effective. Definitely you can apply even evaporative cooling fundamentals in those areas also. But from an overall efficiency perspective, it will be very less efficient. So that's why where you are deploying those data centers which are running these LLMs is also very important, whether it is windy north, whether it is coastal area, whether it is urban core, and depending on what type of area you choose, the different type of cooling design would be different. So that's why this aspect is also very important. So when we are talking about LLMs, right? And people think that LLMs is only for computer science. No, when we talk about the subject holistically, the data center plays a very role. And in data center, cooling, the heat coming, how do you dissipate that heat which is coming out of data center is very important. Where you need other engineers, um, the people from other engineering background also to make it more effective. It's not only computer science folks or maybe IT folks who are going to build the whole solution. There are different roles from different engineering which are very important to design the most effective system, which is sustainable and long term. Now, again, when should we answer, which we talked about, right? Depending on the time of the day. Now, there could be some problem statement which need answers in real time. Like, for example, if you're asking for an immediate information. But if you're analyzing something, maybe I'll put 10, 20 analysis to work at the background. And then maybe tomorrow I'll come and I'll get all the reports, right? So that should also work. So depending on your problem statement, you should define whether you need immediate answers or you can have answers later. And from a deployment perspective also, when should an answer when should be a query should be passed to a particular data center versus the other data center, that also can be decided, right, depending on the time of the day. That's what we are talking about. So it's where, when, and then there will be next aspect to it. Yeah. Again, this, I wanted to make it more interactive from this perspective, but this gives you an idea of water consumption, right? Depending on which area, which I briefly touched upon in my previous slide also. If you are dependent on evaporative cooling, right, and you deploy your data center in a dry area, your water consumption is going to be very intensive. Right? This is what it is written here. In many regions, summer cooling makes inland sites 4x more water intensive than coastal closed loop systems. Versus if you deploy your data center in humid regions or coastal regions, your energy consumption will be, or rather your water consumption will be less. So there are many other aspects while you are deploying, and this is more from a supplier perspective now we are talking about. Initial slides which I showed was more from an application perspective. This is more from a supplier perspective. Whether supplier is OpenAI, whether supplier is Microsoft, if they are building their data center, they need to be aware of, or if you are doing research on this, how you will come up with the framework on how a data center should be designed from a sustainability perspective. That's where it is important. This is very important, which is already been taken care by most of the companies. Like, for example, Microsoft has a lot of data centers in Norway. Now, Norway is one of the coldest country in the world, right? Now, why they have a lot of data centers in Norway or any colder region is basically they are using the heat which is coming out of data center in domestic heating, right? So what we are essentially, yeah, sorry, someone is asking anything.
बटाट्याची भाजी, कांदा भजी, लोणच्याची फोड. Yes.
Mr. Jitendra, do you have any question? Can someone mute him if he doesn't have? I think, yeah. Okay. So basically, what we are talking about here is you can deploy data center where you can utilize the heat which is coming out of this data center for some other purposes. And again, Norway is one of the best examples. Microsoft, you can research about Microsoft. Most of the data center, they are even deploying data center inside the seas and oceans. But there are data centers in Norway which, when dissipate heat, is used for domestic heating. So these are also the things which people are implementing to take care of the overall energy consumption from a design aspect standpoint, right? State versus rack. What does this mean again? This is another aspect. Like, for example, if I'm buying a GPU, if my company is taking or some leading or driving an AI initiative, whether I need to procure biggest GPU possible so that I can run any model, or I can stack them, I can start smaller, first try to realize value from what I am building, and then go to the wider adoption, right? And this is a better also from the way research is moving today. If you go just 1.5 years back or 1 year back, the model sizes are continuously reducing and the efficiency is continuously increasing, right? So if you end up spending more on GPUs, or if you end up deploying higher GPUs, you are unnecessarily wasting money, and also it will lead to more energy consumption also, because the hardware which you are deploying was not necessary. Now you can run smaller models, which lead to inefficiencies. So this is also one of the adoption strategy which people can take off when we talk about energy reduction. Now this is nothing but a hygiene, wherein you can have a dashboard which not only talks about ROI in terms of money, but also in terms of energy consumption, carbon reduction, heat recovery, and all that stuff, which is very obvious and hygiene. So this I have summarized here what we should do when we talk about low carbon inference pipeline, small first routing. We talked about it. Aggressive patching and routing. We talk about speculative decoding, carbon aware temporal scheduling. These are all different terms. Don't worry about technical jargons used here. You can just hit on explanation, you'll be able to do. Whatever we just discussed in the previous slides, this is all summarized here. Last part, whether you always need an answer in real time, no. Depending on the problem statement, the system should be designed. And whether you need answer in 1 second versus 3 seconds, depending on how urgent that is, right? Because even the latency increase from say 1 second to 3 seconds will reduce your CO2 consumption, right? At the source. So as a user also we should be aware of, and as an application developer also we should be aware of what latency would not matter, right? Unnecessary defining it for very quick inference pipeline does not make sense always, because neither from an monetary perspective, neither from an energy consumption perspective. Make tokens follow the wind and the sun. This is just a quote wherein we are talking about if you follow where is the wind and where is the sun, or basically what is the location you are deploying your LLMs or data centers, you would be better off in terms of designing your solution for better climate and more sustainability. That's it. That's it from me. Any questions? Open to questions now. Thank you, everyone. I'll stop sharing. Yeah.
Participants, if you have any questions, you can please ask. You can unmute yourself and ask questions.
Anybody? Or was it so confusing? See, it's a vast topic, or rather sustainability itself is a vast topic. And then within that, if we talk about LLMs, AI, that itself is a very vast topic, right? You cannot cover everything in one go. I have tried to squeeze that in one session, because even if I talk about only ML, the first part of it, the definitions, it will take 1 or 2 hours, or rather we can talk about, I take a course on ML at ISB, which is 10-hour course only on machine learning. So that's how it is. There are questions, I guess, in chat.
Yes, we can see chat.
Because I have learned that heat recovery is possible beyond 120 degrees. No, so it all depends, right? So I'll give a practical example. There is something called condensing economizer, because I worked in Thermex for 10 years, and there is a patent which we have filed in around condensing economizer. So condensing economizer was been around in European countries for a longer time, right? And now what is condensing economizer? Wherein the temperature which is coming out of the boiler is at 120 degrees Celsius, say, or 140 degrees Celsius, and you can reduce down that temperature to 60 degrees Celsius. Now, when you reduce down that temperature to 60 degrees Celsius, and if you're using something like natural gas, your SO2 gets condensed and it becomes H2SO4 or H2SO3, whatever, right? It becomes acidic. So they were recovering heat from this condensation also. And that's why it was called condensing economizer. Now, when we reduce down to 60 degrees Celsius, the other side of fluid, you cannot heat more than 120, because the inlet is 120 and the outlet is 60, right? But in European conditions, because they already have very cold climatic conditions, it was possible to reduce into one below 60 degrees also. So it all depends on the geography. When we talk about 120 degrees, not a hard constraint. It depends on what geography and what type of problem you're talking about. This is already being done. Can be submerging data centers underwater. If you read about how Microsoft is doing, they are already doing this. And there is a lot of information. So my objective was not to give the information session because information you can also gather from internet, right? Even if you run something called deep research on ChatGPT, it will give you a big research document on this particular topic. So information you can gather everyone. My objective was to give you a perspective on how things when we talk about from a design perspective or more from a research perspective, how we should think about this problem statement and what all aspects are important. And there are many more than this what I have delivered. Few of them I have tried to cover in this session. Any other question? If I have missed any question from chat. So I would recommend anybody from non-IT, non-computer science background should also try to do research on AI and AI application in other engineering functions also, because it's going to be there in every other domain and every other function, right? So it's important that you also start using it or start applying it in your respective domains, which is going to be very important. Thank you everyone. Yeah, over to you, sir.
Thank you very much, sir.
Yes, thank you very much, sir. As we conclude the today's session, I must say, Mr. Rahul Kharat, he gave more knowledge in less time. As we say that energy efficiency is doing more with less. Thank you so much, sir, such a nice session you delivered. I also thank all our enthusiastic participants for their active involvement and participation. Thank you, sir.